Okay, so some more people are coming in. I guess a lot of people didn't know that this place existed. So, so welcome. Thanks for joining us here. And just so you know, we are streaming and recording. So I'm also saying welcome to those people from the United States or from around the world who decided that they wanted to attend remotely. So this is the first Art Sci Salon of the academic year 2017-18, and it's also a laser TO event. Nina Lady will say something about it, but just so you know, laser is part of the Leonardo network, and that's our connection to the international network of art and science community. So I just wanted to, before I start, I just wanted to do a quick and very important acknowledgement. I wish to remind you that we are sitting on sacred land, of course, and there have been this has been the territory of the Huron-Wendat and Petun First Nations, the Seneca, and most recently the Mississauga, the Credit River, and it's been their land for over 15,000 years. So we should remember this. But then I also need to acknowledge our sponsors. So this event would not exist if it wasn't for the generous hosting of the Fields Institute, which is where we are right now. Some generous sponsoring from the Ontario Brain Institute, and we also thank the Matteo community, which is a community of science communicators, and they are doing everything on a volunteer basis, and they've been fantastic in promoting our event. And last but not least, the Leonardo Network for doing also some promotion internationally. And I would like to invite Nina Lady to say something about the network itself. Welcome.
Good evening. Hello, everybody, and many thanks for coming and joining us this evening. This is an honor to have so many people here. And thank you, Roberta. We have been working quite a lot together. On behalf of Leonardo, the Art, Science and Technology Network, I would like to say just a few words about Leonardo. We are now celebrating our 50th anniversary. It's our journal, which is published by MIT, has been in print for 50 years, but we have several other activities, and one of these activities is the Laser Network, which started in the US, and it is still quite a lot performed in the US, but by now it's an international network, and we are very proud that in Montreal and in Toronto we have ongoing laser programs. Laser stands for Leonardo Arts and Science Evening Rendezvous. I don't want to hold you up because there are many very interesting presentations. Thank you again. Bye.
So let's start. So this event is called Narrating Neuroscience. So it was just through almost by chance, through conversations with our then potential speakers. So we plan to initiate a discussion on the role and the use of storytelling and art to communicate abstract and complex concepts in neuroscience, also to put into communication scientists, technicians, clinicians, and also patients. And much, much more. So we are here to initiate the discussion, and the presenters are very different interests and very different professions. So I'm very excited to welcome them here. For those people who are not very familiar with U of T and the U of T campus, there is an exhibition going on right now that is basically across the courtyard from here. It's in the Koffler Center, Student Center. It's in a corridor that is very well attended, and like people go across all the time, and it's between the Koffler Center and the Baakdhah Center. So if you get a chance to go visit the corridor, there's 3 cabinets that have been installed with works from the students of Shelley from Tahani, and some illustrations by Matteo. But we will see some of these work while we are presenting. So I want to welcome our 4 speakers: Matteo Farinella, Shelley Alfonso Fasano, and Tahani Baakdhah. And the first person will be Matteo. Go ahead. On the side, and then you have the thing. So I'm gonna it's gonna work. Before I turn off the this thing, I just want to say. So Matteo comes from New York. He's based in New York, but he's not from New York. Anyway, Matteo is based in New York, and I don't want to introduce him because I think his work speaks for himself. You want to say a few words about yourself, but it's written in the description, so we don't really need to do any other introduction. Okay.
Okay. Yeah. Thank you all for being here. Can you hear me okay? Great. And yeah, thank you, Roberto, for inviting.
Okay.
Okay. They told me to use this one, so I'm going to try to speak.
Actually.
I don't usually wear this. It's just for... Okay. Anyway. So yeah, thank you for putting together this event, which, as you will see, is really like the perfect chance for me to tell you about these 2 very different things I'm passionate about, and how I'm trying to combine them. So I'm going to start by giving you a bit of my background to tell you how I ended up here. So yeah, my background is a very traditional science background. I studied biology and neurobiology as an undergraduate, and then I moved on to London, University College London, to do a PhD in computational neuroscience. So really, there wasn't much artistic art in it. But throughout all these years, I always had this parallel interest in comics, as you have guessed from my title already. And for many, many years, I kept these 2 things very separate. So I wasn't actively trying to hide my passion for comics, but I wasn't actively publicizing it in my academic environment. Because probably I grew up with this idea that comics are this very, it's definitely not something very serious, not worth of academic endeavor. So, as I said, I was a bit shy about it. And I was essentially doing my science during the day and drawing my comics at night, in the weekends. And I would never even think that there would be a way to combine them. This all started to change around 2012, when Hannah Ross, who then became my collaborator, joined my lab. She was a neuroscientist as well. She was, as I said, she was doing a postdoc at my lab, but she also had a background in science communication, which for me was a very new concept. I never really thought about doing science communication. But Hannah had this interest, and when she was really the first one from the academic environment, the scientific environment. Then when she heard about my passion for comics, she didn't just dismiss it as a curiosity, but she really encouraged me to to draw comics about science, and she thought it could be a great way to do some science communication, to make our subject, neuroscience, more accessible. And I have to say that at the beginning I was quite skeptic. I mean, I thought it would be great. It would be really fun for me to do, but I didn't think there would be a public out there for these comics. Because as I said, I grew up thinking these two things should never meet, art and science. But Hannah really persisted, and I really have to give credit to her, because it's really talking to her that I started to realize that it's not this tradition of comics as something very, very easy, very, very approachable. When it comes to science communication, it could actually be a benefit. Precisely because comics are not really associated with science at all, but they also don't carry the same baggage of other fine arts. Maybe comics could become a sort of middle ground, a neutral ground, to bridge these two apparently distant worlds. So yeah, comics as a way not only to use the visual appeal of art to get people interested in science, but also maybe for us as scientists to think about what we were doing in a different way, in a bit more playful way. And so yeah, this in a nutshell is really is the proposal we wrote to the Wellcome Trust. That, for those of you who don't know it, is like, this is a really amazing organization based in London in the UK, which actually supports a lot of basic science research, one of the major, I think, source of funding for scientific research. But they also really care about science communication and public engagement with science. And so they have these small grants, small and big grants, for new experimental science communication projects. And so we went to them with this idea of a comic book about neuroscience, not very originally called Neurocomic. And again, to my big surprise, they thought it was a good idea as well. And so what started as a sort of side project for me as a hobby, as a kind of like a joke between me and Hannah in the lab, suddenly became a very serious project with the approval of this important institution. And so, I mean, I really want to acknowledge that, because I think that was really the turning point for me. It really gave me more motivation to do this. I mean, I actually had to do it now. And also, I think it helped us later on to find a publisher, Nobrow, which it was still a relatively small publisher at the time, based in London, but they were becoming really famous, especially in the comics world, for their carefully designed books. Their point was really that if we wanted people to buy comics in this century, we had to make them like beautiful objects people want to have. So yeah, this was very much against the tradition of comics as kind of a cheap, disposable entertainment. So they are the one, that again suggested to do this silver and gold foil cover, kind of reminiscent of old science textbooks. And they published the book in 2013 in the UK, 2014 in the US. And I can say, without false modesty, that it was immediately quite a big success. We very quickly got translations in French, Spanish, Italian, Korean, and there are more which I don't know if they're out yet, but they are supposed to come out. And yeah, I was really overwhelmed. Like, this thing that started as a small project kind of took over my life in a good way. And I mean, I still don't know why it resonated so much with the public. I wish I knew, because I could do it again. But I think a key element, which was very clear from the very beginning, from the very start of the project, is that we didn't want to write a textbook in comic format. Because there's nothing wrong with textbooks. I think actually they are very good at what they're doing, and they already use illustrations. But that's not what I think comics are good for. So comics are good at telling stories. And both me and Hannah agree that we wanted to have a strong narrative component. So we made up this like very basic narrative device of a fictional character that gets literally sucked into the brain and finds himself slightly confused in this other world that at the beginning looks like a forest, kind of like this wonderland, and then it will be revealed that it's actually the nervous system, and what looks like trees are actually neurons. And this character is going to go on all kind of adventures, meeting different scientists and other characters, and really has to learn about the brain along the way. So we decided to do this because we really didn't want to be the scientist kind of lecturing the audience, like teaching the science to the audience. And the hope was that this character, this fictional character, would function as a sort of proxy for the reader. So it could, for example, ask questions, interrupt the scientists when they go on for too long, and really maybe like provide an emotional attachment. So maybe the reader doesn't even really care about the brain. He just wants to know what happens to this character. But they will have to learn about the brain in order to go through the story. So this was our idea. And I think that was an important element of Neurocomic. And yeah, as I said, it came out in 2013. And as you may remember, that was also a very convenient time for me because it's when I finished my PhD. So I was trying to decide what to do with my life. And I had to decide whether to stay in academia, look for a postdoc, or do this thing, which I never thought ever in my wildest dream could be my job, but suddenly didn't seem so crazy. And so yeah, I decided to take a leap in 2013, and I just started working as a freelance illustrator, comic artist. And for the next few years, I've been very lucky. I always managed to work with these different projects that in some way or another, they were trying to make science more accessible to the wider public. Not only about neuroscience, about science in general. And this is what I've been doing, yeah, for the next 2 or 3 years. Most recently, I published 2 more books this year. They've been working for a while. One is a children book. Is out in Italian for now, called Cervellopoli, and the idea is very similar. It's a basic introduction to neuroscience, but for younger readers. And again, there's a strong narrative component. So it's the story of a young neuron, Ramon, who has to decide what to do when he grows up. And so he goes on a school trip with his teacher, Camillo, to see the different areas and different neighbors of this brain city, to see what kind of jobs are available. And the other one, which literally just came out this month, or is not out yet, it's not clear, but there is a copy in the popular corridor down there, if you want to see it. And as you can see from the cover, yeah, it's very similar to Neurocomic in terms of design and concept. This time is the story of this fictional character, this woman who goes through this trip through the 5 senses, so the 5 classic sensory receptors. So yeah, touch, taste, smell, hearing, and vision. And I don't want to tell you too much about the story, but the idea is similar, is to have this character that provides sort of guide through the science. And I don't tell much about this one because it's very similar to Neurocomic in terms of idea. I think the main difference is that Neurocomic, as I told you, kind of happened by chance. It grew very organically. We didn't have any master plan. We didn't really know what we were doing, to be honest. This one, when I started writing this one, I think I had the chance to really step back a little bit and think more about what I was doing. So really appreciate more the role of narratives and characters, and really also because it's a much wider subject, as it turned out. I thought the science would be kind of like easy, basic science, and of course, each science is a major field of research. People wrote an entire book about each one of them, so I had to do much more research myself and make many more conscious choices about what kind of science I want to present and how I had to like cut it down to fit it in the story. So yeah, it really gave me, it really forced me to think about what I was doing. And then this feeds nicely to the sort of next chapter of my story, the final chapter, my latest research, which I want to tell you briefly about in these last few minutes. Because since last year, 2016, I actually returned to academia, thanks to this new program at Columbia University, Presidential Scholars in Society and Neuroscience, which has this very ambitious goal of combining neuroscience with other subjects, especially in the humanities and social sciences, and really do something more with a social benefit. And it's very open format, so they essentially ask for proposals. And I decided to basically write the proposal of my dream, which is really to like take a broader view of what I was trying to do, what I've been doing for the past few years, this comics about science, and think a bit more scientifically about this field. So the first thing I did really was like I started looking around, and I realized very quickly that I was not the first, not the last to do comics about science. I mean, I don't know how many comics readers there are here, but I'm sure most of you know that comics now kind of are quickly overcoming the old stigma, and they are starting to tackling more and more complex subjects. In more recent years, there have been a few successful comics about science or scientists initially. But really, like, the more I'm looking for them, the more I find comics everywhere. I don't know if it's just me that I'm paying more attention or they're actually an expanding field. But yeah, for example, in 2015, both Science and Nature, two major science publications, they both published short online comics about science. And yeah, if some of you are interested in science communication, as I expect many of you are, you're probably seeing some of these new platforms online, which they don't exactly do comics, but I think they heavily rely on the language of comics, animations, video games, and all these things that I broadly define as visual narratives. And I always want to make clear that I'm not like defending or promoting any of these in particular. I don't think they all set a good example for science communication. All I'm trying to say is that, like, as a scientist, I don't want to dismiss this as just entertainment, as a trend, because whether we like it or not, millions of people are actually learning about science from these platforms, much more than we can hope to reach with our publication. So, yeah, instead of just dismissing them, let's try to take them seriously. Let's try to understand what are they doing, why are they so appealing, and my hope is that if we understand this, then we can also use them more effectively. So yeah, that's really sort of the starting point of my project. I wanna try to measure the effects of these visual narratives, like comics, in science communication, both in terms of learning, but even more in terms of engagement, attitude towards science. And if there is any, I really want to understand what are the cognitive mechanisms behind this. And yeah, I don't have the answers yet because I started last year, and I have a lot of like background reading to do. What I've been trying to do so far is kind of like move away from comics as a genre, and because there's all kind of problems with the definition of comics, mostly for historical, cultural reasons. So I'm really trying to think what are the fundamental elements of comics. And I mean, these are the main three I'm focusing on. And of course, they're not exclusive about comics. I think the comics just like kind of combine them in unique ways. And since, yeah, the event is narrating neuroscience, I want to spend just the last couple of minutes talking about narratives, the narrative element. So, yeah, last year I really dived in all the literature about narrative communication, which I knew nothing about as a computational neuroscience. And yeah, there is a lot of interesting research in psychology and cognitive science about really, why do we tell stories? Why we do these weird things as humans? And essentially, many scholars argue that the stories are really a fundamental way for humans to understand and transmit information. And I don't have time to go into this, but like, I feel like also I'm not an expert yet in all this, but something I took away, I think most scholars would agree, is that stories are about people, are about characters. And this is a problem when it comes to science communication, because as communication scholars pointed out, we are kind of stuck in this middle ground. And most of like science journalism and science communication mostly cover health and biology topics because these are most accessible to us. They are more on our scale, human scale, and it's easier to find a character in them. But what about the larger or smaller subjects, which we don't have a good understanding, and it's difficult to find a character-driven narrative, these so-called cold sciences. And I think this is really where comics can help, because comics, as many comic scholars pointed out, most famous is Scott McCloud in understanding comics, are very good at personification, at creating characters. So Scott McCloud in particular pointed out that most comic characters are really extremely simplified, if you look at them. They're essentially emoticons. And this is not because comic artists can't draw anything better. I mean, sometimes maybe they don't, but often it's an explicit strategy. And I think this kind of relies on pareidolia, this like fundamental tendency we have in seeing faces everywhere. And Scott McCloud argues that this is a way to create universal characters, universal stories. Because if we tell a story of this guy, then it's the story only of that guy. But if we tell a story of with this character, or even a human character, suddenly everyone, regardless of gender, age, ethnicity, anyone can identify with this character, potentially. And I mean, if this is true, this is just an hypothesis, but if it's true, it could have, I think, major implications for the way we communicate science. And I think it's interesting to note that many comic artists are already doing this. So they often, for example, translate scientific entities, sort of abstract, inanimate scientific entities in characters. Since we are at the Field Institute, yeah, this is a mathematical function translated into a character. Or neuromodulators can become kind of friends that set up a date between two neurons. Bacteria can exchange plasmids as presents. And even more than that, we can have characters as narrators, as guides in these often very distant subjects like ocean biology or evolution, when there is no clear human character. Or in my case, of course, Neurocomic, the main character that gets transported into the brain. So yeah, I think it's interesting. This is really the last thing I want to say. It was very interesting for me to see how this strategy, which I initially used kind of intuitively, I think it may have some scientific backing, and that's what I'm really trying to measure and study now. And yeah, this is really the end. I just want to thank all of you for your attention, and Columbia and my mentors to support me in this project. And if you want to know more about any of this, I started a website, Cartoon Science, where I try to collect comics and animation about science. And yeah, just feel free to get in touch. Thank you.
While we are switching, I just wanted to welcome Shelley Wall, who is from UTM. And again, like if you want to say something about yourself, you're better than me for sure. But I also want to thank you for the nice discussion that we had on the phone and all the fantastic illustrations that you sent me from your students. And they are on display, again, in the cabinet, the Koffler Center.
Okay, is this working? Okay. Thank you, Roberta, and Nina, and thank you all for coming. So yes, thank you very much. Matteo is a very hard act to follow. At the same time, I also hope that what I'm going to talk about will touch on some of the same concepts. So I teach in a professional graduate program in medical illustration here at U of T, at UT Mississauga, out in the west. And so, yes, Roberta has very graciously made those cabinets available, and so I wanted to showcase some of the work of my students in the hallway. So what I'm going to talk about tonight is it's about the connection, basically, between what I do as a medical illustrator and my interest in using comics to talk about medicine. Who recognizes this? This is Bob from Sesame Street singing "One of These Things Is Not Like the Others." I'm not a neuroscientist, nor do I have a background in neuroscience. I have a PhD in literature. I have a degree from the Ontario College of Art and Design in drawing and painting. And I have a Master of Science in Biomedical Communication, and that's where I teach now. And so all of these, so my interest in narrative comes from my background as a literary scholar. My interest in visual narrative comes from my latter two degrees at the Art College and then as a medical illustrator. So I have, as a medical illustrator, I have studied neuroanatomy, and I teach students who have gone far beyond me in working with neuroscientists, neurologists, clinicians, to create images that might explain new work in neuroimaging, might explain basics of neurophysiology or neuropathology, and these are just examples of some of their work and clips from some of their animation. They work in neurosurgery. They do textbook-like illustrations. These are animations for researchers explaining research or new diagnostic technologies. This is an interactive piece intended for undergraduate students to learn about the anatomy of the brain. So, what goes into a successful medical visualization? And I use the term visualization rather than illustration because it has become a very broad field with animation, interactivity, model making, all sorts of other modalities. But all of these media involve close observation or careful research, an understanding of the subject matter. Most of our students are come in as science students, and we've had actually quite a few, a number of people with PhDs in one science or another come and do our program because they're interested in science communication. They've realized in the course of in their career as a researcher, as a scholar, that communicating what they're doing is really important, and often for that they wanted to have the visual tools that they get from our program. Sensitivity to audience needs, patients versus researchers versus the general public or students. Technical expertise, so they come in with artistic skill, spend a lot of time learning different technologies. But above all, what this kind of work involves is good storytelling. Matteo has touched on the power of stories to instruct and to engage. And so basically, as medical illustrators, visual narratives are our stock in trade. It interests me that a concept from narratology, from the study of narrative, is actually quite useful at explaining the process of creating some sort of visual medical media. So Mika Ball in Narratology, which is a kind of unpacks all of the different ways that narrative works, distinguishes between the fabula, which is just the raw material, the series of events that furnish the raw material for a story, and the story itself, which is the result of the specific selection and ordering and focusing and coloring of those events. So as an example, this is not neuroscience related, but it's a good example. This is a textual description of a coronary artery bypass graft surgery. So working from this kind of information and observations in the OR and in close consultation, obviously, with a surgeon, an illustrator will create a visual story by selecting which pieces of that information to depict, how to organize them, where the focus lies, where moments of repetition are valuable, what can be left out, what the point of view is. It's often the surgeon's point of view, but sometimes other, more diagrammatic illustrations might be necessary, schematic. So making all of those kinds of decisions, how do you pace the story, where, how much time is spent on each stage. And we see this visual storytelling in things like this. This is a beautiful, this is a piece of student work. This is a beautiful professionally done illustration from a recent issue of JAMA about the different drug mechanisms of action in Parkinson's disease. And so you can see here, there's a selection of how do we depict the setting? Where's the scene where this action takes place? Who are the characters? How many of them do we represent? How do we achieve emphasis by using these warm colors here, using desaturated colors to indicate the dying off of the dopaminergic neurons? How do we cluster these separate events together so that they can be easily compared? So there's a lot of narrative technique involved in putting together these kind of explanatory illustrations, which is a lot like comics. I also have my slide from Scott McLeod, who defines comics as juxtaposed pictorial and other images in deliberate sequence intended to convey information and or produce an aesthetic response in the reader. So this kind of narrative can be carried over into more explicitly comic form, as in Neurocomic. And this application of comics in fields of medicine, which is mainly where I work, but medicine, bioscience, all science, has become a field known as graphic medicine, which is, I don't know if you can read the definition here, but what is graphic medicine? It is the intersection of the medium of comics and the discourse of healthcare. This is a page from an academic publication called the Graphic Medicine Manifesto, which is partly in comic form, exploring comics as a form of scholarly discourse, and partly in more traditional textual form. Graphic medicine combines the principles of narrative medicine with an exploration of the visual systems of comic art. So this field of graphic medicine, I'm going to talk a little bit more about the different things that this encompasses. But the most obvious connection of graphic medicine with what I did professionally and what my students do is in the creation of didactic comics. So comics that are for example, for patient education or public outreach. The Wellcome Trust actually has funded a number of beautiful comics to explain to the public what their research, for example, in parasitology that is going on and with their funding. So these things can do, didactic comics can raise awareness about conditions. It can prepare patients, for example, for a procedure, promote the management of chronic conditions. It's non-threatening, it's accessible, it bridges literacy barriers. And this is an example from a series called TBI Info Comics, which is a series of comics that translate information pamphlets about traumatic brain injury into comic form by introducing characters. There's a family whose members has been affected by traumatic brain injury. His sister sets out to learn about the brain in order to understand what her brother is going through. There's information about what they might expect in terms of his changes of behavior, his needs, what he needs from them, who the different therapists and healthcare workers are that he'll encounter. This is another didactic example, a beautiful little chapbook called Pain is Really Strange, which explains the neuroscience of pain. And this is a comic with references at the bottom of each page. Sarah McNichol, in an article called Humanizing Illness, says, health information comics have the potential to do much more than simply convey facts about an illness. They can also support patients in dealing with the social and psychological aspects of a condition. And so this is where I want to kind of segue into different kind of comic, which is going beyond information, going beyond didactic presentation. And that is a problem with didactic comics in that as a medical illustrator, it's important, it's art, but it's important that it be unambiguous, not polyvalent, not raising all sorts of interesting questions, but that it communicate a clear message that is ideally the same for everyone who reads it. Even while it has, there are obviously affective elements, aesthetics and other ways of appealing to people's affect rather than, and not just cognition. But this idea of comic that conveys something about the social and psychological aspects of a condition brings in another area of graphic medicine. So if you have information comics, there's this big web of possibilities that goes under the rubric graphic medicine. And this includes, somewhere else in that field, connected in some way, a genre that has been called graphic pathography, or graphic memoirs. So people writing comics not necessarily funny, but sometimes funny, about their experience with illness or as caregivers or as healthcare workers, to capture those sort of more ambiguous or some messy aspects of healthcare and health and illness. So these are stories of illness and caregiving that might be told by survivors, patients, family members, healthcare workers. And the idea is that these reflect sort of on the culture of medicine, or on what it means, what it's like to be ill, what's the subjective embodied experience, in addition to what is going on physically in the body. They convey the subjective patient or caregiver, care provider experience. And there are some interesting neuro-related comics in this regard. I realize this is too small to read, but I want you to get an example of the kind of ways that image and text are being used in these comics. This is by an artist called Tyler Page. It's called Raised on Ritalin, a book that just came out, I think, last year. And it's a book about his lifelong, about what it's been like for him to live with ADHD for many decades. And this is interesting in that it combines these sort of instructional, almost medical illustration-like images that explain something about, the neurophysiology of ADHD, and then what it's like to have ADHD, how it's difficult to hold a conversation, how his brain is constantly jumping from topic to topic and effectively actually obliterating the conversation. And so this is a way that comics are really, really valuable in that kind of visual shorthand where his thoughts are literally blotting out what is going on in the present moment. This is a comic called Dad's Not All There Anymore by Alex Dimitris, about his father's diagnosis with Parkinson's and Lewy body disease. And here too, he's got this sort of instructional. The family has to research Lewy bodies when they hear this word in the course of a consult, and then this description of what it's actually like for his father having these hallucinations, the effect, the toll it takes on the family as he declines. So I just want to move into the last part of my presentation. This is a medical illustration from a textbook of neuroanatomy. I think the illustrator is having a bit of fun here with this schematic neuron. I came to that page and I thought, oh, I know what I have to do with this. So I turned it into a neuron with Parkinson's disease and coctocornia. I teach a neuroanatomy illustration course. I teach these students who do amazing work with advanced neuroscientific research. But my most immediate contact with brain science has been as the caregiver of a person with advanced young onset Parkinson's disease. And so in that role, I've seen neuroscience in kind of a different light. So you all know what Parkinson's is, and I'm embarrassed to be explaining this in front of the head of the Movement Disorders Clinic at the Western. But so here's a cross section through the brain. It's the midbrain in the center, and this substance here, that's the substantia nigra. These are the dopamine-producing cells that are necessary for movement, and they contain a dark pigment called neuromelanin. And what happens so those cells enable you to move and be a joyful neuron. And then what happens in Parkinson's disease is that those neurons disappear, and then you run into trouble. You lose the ground that you stand on. And so as this one dark substance disappears, another kind of darkness arises, and that is the subjective and the human complexities that follow from this kind of a diagnosis. I want to this is not my work, this is the work of a magnificent artist called Peter Dunlap Scholl, who was in fact a professional cartoonist when he was diagnosed at 43 with Parkinson's. He says, since around 2000, I had a small and painless twitch beating regularly in my left foot. A trip to the doctor to uncover the cause yielded a shock. I walked in with a seemingly small disorder and walked out diagnosed with a catastrophic disease, Parkinson's. I was 43, and yes, that's too young, as if there is a good age to have it. So what does it mean to have Parkinson's? And then there's this list of, here are the clinical symptoms. Parkinson's is progressive, disabling, and incurable. I left my doctor's office pursued by questions. So his questions are not about Parkinson's disease, as they're not the questions that you would find if you turn to a manual of pathology. I remember reading a description. It was on the handout that came with a prescription for levodopa. And it actually started with something like, did you know that Parkinson's was named after Dr. James Parkinson? That's not a question that he is asking as he leaves the doctor's. His questions are, family, how much time? So these are not questions about neuroscience. And in this darkness of the diagnosis, I also started to use images not for explanation, but for exploration, to try to think through for example, all the questions that are asked about, well, where did this come from? Are there environmental factors? Are there family? Is there a family history, which is unknown? It was explained. I also started to use images as a way to understand what it was like for that person, because one of the things that he would often say is, if you don't have Parkinson's, you can't possibly understand what it's like. So what is it like? And metaphor was the way that he used to explain what it felt like to be him, to be in that body. He said it's like you're a sailing ship that is supposed to be crewed by 50 men, and the crew starts to die off until you're operating with a skeleton crew that simply can't crew the ship. The body is there, the muscles are there, the crew members are gone. Also to try and explain what it felt like, what the initially afflicted limb felt like at different stages. So, that's okay. So that's just sort of a very brief kind of arc from medical illustration to where my kind of personal work intersects with stories of the brain. This visual narrative in medicine can be explanatory and exploratory. As visual communicators, we shape our observations and knowledge into visual stories. And as humans, I think we share stories to inform, to connect, to reflect, and also to process experience. You will be. You will.
We are switching the computer. What are you looking for? Okay, great. So I'm very happy to also have a representative of the medical community with us, and Alfonso Fasano, who some of you know. I get that you're quite popular, quite famous. Not just because you work at the hospital, but yeah. Well, so without further ado, I'll let you speak for yourself. You're using the microphone that will be handed to you by. Thank you. There's two more there, but we're actually sharing these.
Can you hear me? Hello? Can you hear me? No.
I think I can hear.
Okay. Okay.
You can run.
So good evening. It's a pleasure for me to be here. And the strange part of this story is that I'm the doctor, and you heard a lot about neuroscience, and particularly Parkinson's disease. But I'm here to tell you that Parkinson's can also be an opportunity, not just a black screen that you showed before. And I think my job today is to tell you that Parkinson's can shed light on understanding what creativity is. I mean, at the end of the day, I don't have the answer myself. I'm just going to give you a few hints on what I think creativity can be, or at least few components of creativity. And before I start telling you more about it, I want to show you this video that I'm sure you recognize. This is probably my favorite director, Kubrick. This is The Shining. And I'm sure you know that this moment of the movie, the people, all the audience and the watcher realizes that what this actor, Jack Nicholson, was doing wasn't just writing a book, because I don't know if you remember the story, he's a writer and he's there to write his book. But then at this moment, people realized that he was writing over and over again the same expression, maybe in different ways, as you see. But the question is, what is this? Is this art? Is this creativity? And this is the reason why I love Kubrick, because he was the first one showing to the public something that at this moment wasn't known yet in the medical field. And if you want, even 2001 A Space Odyssey, I don't know if you know that, but he shows many things that at that moment wasn't known, because he actually shot the movie even before the man was on the moon. So you already heard about Parkinson's. You already heard about substantia nigra and this part of the brain that produces dopamine. I want to just give you a different way to look at dopamine. This is a way we measure dopamine in the brain. This is a normal DAT scan, and what you see there is dopamine. This is the same patient with a progressive degeneration of dopaminergic neurons, meaning that as you see, as disease goes by, there is less and less dopamine. Along with this, you heard another term tonight, Lewy bodies. And Lewy bodies are particular inclusion in the neurons. They are a marker of the neurodegeneration you see in Parkinson's. And this is according to a theory of a very interesting German guy. His name is Brack. And according to his theory, in Parkinson's disease, there is a progression of the neurodegeneration that follows a specific path. When the degeneration is here, you don't have dopamine, as you heard before. But the point here is that along with this type of degeneration, there are the involvement of other areas of the brain involved in other functions, and particularly the frontal lobe, as you see there. So the frontal lobe is something that makes us humans. If we have problem solving, if you have strategies, if you have thoughts, maybe religion, moral thoughts, paranoias, whatever, it's because we have a frontal lobe. Good or bad that is. What dopamine does, on the other hand, is not just make us move. Dopamine is also involved in pleasure, in motivation, in many other things, including addiction. And this is when the story becomes interesting, I guess. So the goal of tonight is to let you see how I think Parkinson's can help us understanding what creativity is, and particularly what I call the creative drive. So my topic tonight is not really to tell you what happens in people with Parkinson's, actually in artists when they develop Parkinson's. But I want to give you just a few ideas, just to also cover this part. So what you see here is the production, actually I probably need to use this, I use my hand. So what you see here is the production of a Japanese patient with Parkinson's. But at this moment he doesn't have Parkinson's, he's just a painter, he's a painter. And as you can see, he has a very abstract representation of the objects of his interest. Around 2004, 2005, he probably started having some symptom. At this moment, he's not diagnosed with Parkinson's, but everybody can clearly see that the production changes. Even when he doesn't have any motor problem, he starts being more concrete. The object of his representation are very different from the abstract art they was doing before. An additional layer comes from the effect of medication. So this is a painter with Parkinson's, and this is what happens as the neurologist increases the doses of his medications. So the medications we use for Parkinson's are based on dopamine, because as you heard, it's the neurotransmitter that is missing, or sometimes they do a job similar to dopamine. We call these medications dopamine agonists. But the point here is that we need dopamine, as you saw before, in a particular area of the brain, but you cannot really tell the medication where to go. So the medication goes in many other areas, particularly, I would say, the visual, the occipital cortex, which is involved in visual and visual spatial activities of the brain. And this is when and now the way these painters do their job changes. These medications are also related to sexual activities and also sexual desire. And it's very frequent that particularly young patients, when on this medication, develop an increased sexual drive that we call hypersexuality. And this is when the topic changes also. This is the painting of the drawing of a patient with Parkinson's, and this is what happens when he develops hypersexuality. So this is what happens to people with an artistic background, to artists, when they develop a disease. And I could say a lot more, but I think the topic tonight is to talk about something else. So this is what happens to someone with Parkinson's and no idea about art, no artistic expression whatsoever before Parkinson's. when the disease starts and when the doctors gives him or her a medication. So actually, in particular, this is a woman. It was followed by a friend of mine in France, and this woman was painting everything with a blue color, even as you see the washing machine. And she claimed that this was art, and this was her hobby now. She had become an artist. So what is this? I think that this is very similar to what Kubrick showed, and it's something that we call now panding. Panding comes from the Swedish literature and means put something in your head, and actually was described in the 70s in people who were addicted to amphetamine. And this is an example of a pander. As you can see, this is not art. It's not an artistic expression in any form or shape. But this person is spending hours and hours with no awareness collecting objects, organizing objects. And the interesting part here is that this happens also depending on the background of the person. Women tend to collect buttons. Men used to collect documents or to use computers. They tend to garden a bit more. But I like that we have these two screens now, which I wasn't expecting to have, because I want to show you this other activity. I don't know whether you can recognize the hands of this man, but in a way, I mean, this might be too much to say, but what this person is doing is not very different from what you saw before. Well, this man here that you can see in a second, this is Pollock. So, and this is just one of the many footage of what he was doing. As you probably know, he's famous for his dripping painting technique. But in a way, when an artist is trapped into a creative process, it's not that different from a panding Parkinson's patients, because they are in this sort of loop. They cannot get out. Sometimes, I mean, probably the artist in the room can confirm. If they want to pee, they don't go to the washroom. If when they are hungry, they don't go to the kitchen to eat. If they are sleepy, they cannot fall asleep because they need to continue what they're doing. And for those of you thinking that talking about Pollock and science at the same time might be too much, I also found particularly interesting that there are people, and this is a publication in Nature, using fractal theory to explain the Pollock's painting. And actually, in this particular paper, they're using fractal theory, which is called fractal expressionism, to prove when a painting is original or not. Because it sounds strange, but what Pollock was doing was actually following a given scheme that he didn't even know, probably. But let's go back for a second to the painting of the man with hypersexuality. And I want to direct your attention to something else in this painting. At this moment, this person is writing over and over again the names of the doctors that he's meeting in his life and at the hospital in a very repetitive and detail-oriented way. And that's another thing that is in common with panding, and I would say also to many artists. This is a patient that I happened to follow years ago with panding and computer addiction. He used to work in a bank for many years using computer every day. Now he's retired. He has Parkinson's. And he starts doing this every day. He colors with different colors, each cell in a very organized and ordered way, the Excel sheet that you can see in the picture. And he also writes sentences that are now, mainly covered, but there are letters. So what seems to be very disorganized, I mean, everything is very organized, but what seems disorganized, which are these letters, are actually very organized also. And this is linked to another feature that these people have, which is the fascination with repetition. So this issue of repeating over and over the same thing in a looped way, which seems to be common to some art at least, it's very common in people with Parkinson's developing this panding. And when you combine things together, artistic drive, repetition, you have this. This is a patient of mine with panding who kept giving me as gift this piece of art that she will do, repeating over and over again what she found written on my business card with different colors. And the other thing that this is that makes a similarity between artists and people with panding is that they have a certain type of narcissistic personality or egocentric way of looking at themselves. So they want everybody to see what they do. They want everybody to say how good they are. I'm sure that many artists in the room may agree that the personality of the artist is very narcissistic. And people with Parkinson's developing this increased creative skill also share this feature that I found particularly interesting. Another thing that is in common here is the addiction, the part of addiction. I mean, Pollock, in the example I gave you before, was an alcoholic, actually died because of that in a car accident. But we went back to people with cocaine addiction, active users of cocaine, and we found that in some cases they were doing some sort of funding activity, doing over and over again the same activity. So now the question is this art? So are these people producing this piece of work, like in this example here? I really like this double screen. I say very interesting. So very good. So the question is this art? And my short answer is no. So these are not artists. Different stories, an artist that develops Parkinson's later on, but I don't think that someone that is not an artist can become an artist just because you're giving him or her medications. But they like to, as I said, show what they do. And there are exhibitions. This is, for instance, an exhibition done in Geneva, I guess, a while ago. These are 13 Parkinson's patients with no creative skills whatsoever, but they started to do creative work. And there are many layers here. In some cases, it's probably a pre-existing passion, it's an habit, it's a possible way to escape the disease, which is all very human and very understandable. But I still found difficult to call these people artists. What I think they have is an increase of the creative drive. And that's one of the messages I want to give you tonight. I think that creative is one thing with multiple domains, and one of these domains is actually the drive, the desire to do something and to keep doing that. And the question here is, what is creativity? So I guess nobody will call a banana a creative action or a creative picture, but if you put this out of the context and maybe you're using a different way, like in this example, you may say, okay, this may be creative. And probably we don't have a good definition of creativity, I guess. Creativity is one of those things, we were talking about this with two friends a few nights ago. Creativity is one of those things that everybody knows what it is, but when you need to give a definition, you don't actually have the words. A possible way to explain what creativity is starting from something that is established and using a different context, a sort of a divergent thinking. And how can we explore creativity? Well, it's very difficult, and I should also say that there's not much money for research in this field, and what I do in this particular field is actually just sort of a hobby, because my job is actually treating patients. My job is much more boring than this, unfortunately, but still rewarding, I would say. So how can we measure creativity? This is an example. So what you might do is presenting someone with two visual stimuli, and you ask this given person, please draw something starting from these two stimuli. And this is what an artist will do. This is actually a real artist, and as you can see, here we have two different, very important aspects. One is the execution, so the artist can do the drawing in a very good way, because he's an artist, and also the creativity here. So these two visual stimuli are used to tell a story. And actually, I really like what the previous speakers were saying, talking about the role of art in communication. At the end of the day, we don't know why we have art, but I think one of the most important function of art is communicating something. So this is what an artist will do. This is what a normal maybe is too much to say, a person without any problem will do. As you see, the execution is not as good, but still, this visual stimuli are used to and embedded in something. This is what a patient with Parkinson's will do, F. And as you see, here the story is much more different. Execution is basically nothing, and there is no creative drive, if you want. And another interesting part here is that, as you see here, this patient with Parkinson's is following the line. So this is something that is called closing in, and it's something seen in people with dementia, actually, when the person cannot move away from the stimulus. This is instead what a person with Parkinson's and increased creativity will be doing. And as you see, again, execution is not good, because in order to be a good painter or a good artist, you need the whole brain. You need to be trained. You need to have your own skills. But as you can tell, the creative drive is much, much more. So this person has really a lot of ideas a lot of lines to draw there. So going towards the end of my presentation, I felt that probably I should have gone a bit more into the medical part, because at the end of the day, this is my job. And we know that there are an easy way to divide human behavior, human motor acts, is dividing motor act into involuntary and voluntary act. But at the end of the day, the story is much more complex, because there is a lot of gray areas. There are a lot of things that we do without realizing that we are doing it. And there is also a whole field of neurology that are now looking at what we call involuntary. Something that is done using the voluntary cortex, but with no awareness. And in this scheme that we published a while back, we tried to put together a number of conditions that are known to affect the motor function of people: tics, stereotypies, mannerism, compulsion, and many other things. And what I found particularly interesting to bring to your attention is that when you look at stereotypies, you're dealing with something that is looped, again, over and over again, but is not goal-directed. In a way, pandas have a looped movement that seems to be goal-directed, although very often is not, while for sure an artist, although not always clear, is doing something with a goal, and maybe this goal is communication. So this is my last slide, and this is just to try to put all the things that I said so far in a single picture, trying to give you an idea of what I think we are talking about. And again, we're talking about Parkinson's in particular. You heard about nigrostriatal degeneration, so the lack of dopamine that with disease progression is always more evident, and we try to supplement giving medications to people, but also frontal lobe involvement. You heard about this at the beginning. Frontal lobe has also an important function in controlling our action. It's actually the lobe that tell people not to do certain things, Freud used to say that this is the part of the brain that is soluble in alcohol. That's when you're drinking, maybe your frontal lobe goes away and then you're a bit more disinhibited. But anyways, when you put these two dimensions all together, you can see how normal situations like habits, we heard from Matteo before, they used to draw comics. Habit is a normal action, of course, but it's a normal human repertoire. But as the things get worse, particularly in Parkinson's disease, then you can explain, particularly because of the effect of dopamine on these receptors, D1 and D2, which are a given family of receptors in the brain, why you might have panding or stereotypies or maybe an increased drive for art or artistic expression, addiction. There is something that is in common, I think, between artists and people with Parkinson's, and also DDS. DDS means dopamine dysregulation syndrome. These are people who become addicted to the medication for Parkinson's. So they keep taking the medication even when it's not needed for motor reasons. So at the end of the day, my job, I think, was just to give you a few ideas. And as you remember, I started by saying that I think Parkinson's is an opportunity for us to understand this is important and fascinating human behavior that is being creative, being artist. It doesn't tell us what art really is and what really means and what creativity really is. I mean, as I said, it's very difficult to say. But at least give us an idea that probably creativity can be decomposed in different domains, one of them being the drive, that is probably connected to pleasure, to the desire of being exposed, to exhibit what you're doing, and possibly to hypersexuality and addiction. So I think this is, and the narcissistic behavior that I was saying before. So I think, in a way, these things, they all fall together. Different story, as I said many times, I guess, is the actual production, is the actual execution for which you really need to be an artist. And with this, I thank you for your attention.
So we have one more speaker, and then we will do round table. There's so many ideas that came out tonight. So the last speaker is Tahani Baakdhah, and oh, sorry. There you go. You just have to start. Okay. I just want to say, for those people who joined because they are knitters or they were very fascinated by knitting, etc., and knitting scientific items, Tahani has started the Knit-A-Neuron Toronto network, so you will probably say something about it. But I really encourage you to, if you know how to knit and how to crochet, to do your neurons, to download the items, and then do something. Take a picture and post it on social networks. So, thanks.
I'm happy to be with you all today, and I want to thank Roberta and our
She wants you to
So I'm happy to be today with you all here to share my passion to science and for art as well. And to talk a little bit about my crocheting neuroscience models that I'm using for science communication. But first, let me introduce myself. I'm Tahani Baakdhah. I'm a science communicator, and at SciComm Toronto, I am Magazine, SciParty, and SciBlog Hub. So I do a lot of science communications on social media and on real life, and in real life as well. So first of all, I'm a physician. I got my MD back in 2003. And then I proceeded to do my graduate studies in molecular genetics, medical molecular genetics, and I got my degree in 2011. Now I'm a PhD student at the U of T in my 6th year doing stem cell research biology, studying the development of the eye, stem cells, and degenerative eye disease. So with all of that, with my passion to science, doing science every day, looking under the microscope, seeing cells, feeling creative, doing art at the same time, maybe you're gonna ask why I'm doing sci-art. So first of all, I like art. I feel like art is really a powerful tool to educate, illustrate, and to translate complex science concepts to people. And with my all crochet skills that I have, and artistic soul and mind, and love to science and art, I turned my PhD project, which is the retinal research, into art. Crocheting all the type of cells in the retina, putting them in illustrations, getting them down in the street, to schools, to public and everywhere, and telling them the story of the retina, how it was built, and what's the degenerative eye disease, and how can we repair them, all using crocheted models. So I'm really passionate about it, and I'm building now the retina, but not in the lab with stem cells. I'm building them with a hook and with a yarn. So every day I put stitch over stitch to make these wonderful models that everyone is enjoying nowadays. And I use my creations as a model to translate my complex science and communicate it with public and students, and also on social media. So I'm accessible on social media. I share my science on Instagram, Twitter, Tumblr, everywhere, and I like to explain my science and also other scientists' research. So I started all this in 2010 when I first got motivated, seeing a lot of crocheted artists on Instagram sharing their wonderful work, and I said to myself, why don't I try? I was in the beginning of my graduate or master degree. I had 2 kids at that time, but I was saying, okay, I need the time to relax and to feel creative a little bit, away from my kids, away from my graduate studies. So let me start learning some crochet. And that was the start. I was self-taught, so I got to the YouTube. I started to watch videos, practice myself at home, daily practice, download patterns, and then I got motivated by others. And once I got motivated by others, I started to do my crochet journey with doing some small toys for kids, actually. So I was first inspired by my kids, doing some toys for them, and then I started to share my love to dolls and to amigurumi, which is a stuffed dolls with Japanese term for stuffed dolls, with others as well, my friend, my family, and then I extended to an Etsy shop even. After that, once I got to the end of the master's degree, I was thinking, why don't I translate the things that I see under the microscope into models? Why don't I share my passion to science using models? I was searching around for patterns, but it was really difficult to find patterns explaining and doing some science art. So the thing that I started to do is making my own pattern. Like whatever I see under the microscope, I hold the pen and I start making my patterns, and then I translate this pattern into a model. And that was really my start in the science crochet. But I haven't really used these models in science communication until in the beginning of this year, when I joined the SciComm Toronto, and their director, Ilian, told me, hey, Tahani, you are creative, so you do science every day, and you know how to crochet, make patterns. Why don't you use your creativity and your science and passion to science in science communication? So I'm already communicating my science on social media, but not with crochet model. I share every day live in the lab, on Tumblr, on Instagram, and talking about science every day, but not with using my models. So once Ian told me about this idea, I started to say, okay, this is so great, and I want to do it. And but I was looking for the time to do it, actually, because now I'm a mom of 3 kids. The youngest is 4 years old, and I'm doing my 6-year PhD. I want to graduate soon. I want to write and finish. But my passion and my love to creation and to creativity and to science was overlapping my thoughts. So I agreed with Rianne, and she told me about a project that she want to bring for the first time to Toronto, which is the meta-neuron. So this project was first started in the UK under the supervision of Dr. Annie Cook and Helen Heatherstone. And Ariel brought this idea to Toronto in collaboration with Ontario Brain Institute. And we did our first workshop in the Maker Festival back in June 2017. This event was really such a great way to communicate with public in a public library, explaining to them the complex concept of neuroscience, answering their questions if they have anything they hear from families, from themselves, about diseases, neuroscience in general. So what I was doing is teaching them the patterns, how to do this neurons, chatting them with them about neuroscience, and answering their questions. And this was really a great successful event because we got a lot of positive feedback. And even those without basic knowledge about crocheting or knitting, at the end of the day, they learned so fast and they were so creative, and they shared with us their neurons at the spot, and some of them even like continued the pattern at home, and they tagged us on social media. And we were so excited and happy that people like got these in a positive way. So we wanted to do it once again after all the positive feedback. And we got all our crochet hooks, knitting hooks, and went to Etsy made in Canada in September 2017, and talked with them as well about neuroscience and teach them how to do this wonderful neurons as well. So it was really great. And after then I started to teach these workshops even to students in elementary school and students to high school, and even in a pop-up market like this. I then liked the idea, and I started to say, okay, I need to also not only use my models in science communication in schools or in public places, but I also want to use them to increase awarenesses for special events or medical days, awarenesses days. So I started, for example, to make some crocheted stuff for breast cancer awareness, for cerebral palsy, for mental health awareness week or month or whatever. And they were really shared a lot on Twitter and on Instagram, and people liked it, and even they were even reposting it and tagging me saying, hey, this is really a great information about mental health, about breast cancer and whatever. And I also started to take these my crocheted neurons not only to schools but also to people in a Soapbox Science Toronto last September, where I took my crocheted neurons and went to talk to the kids and the science literacy week over there, and kids really like it, and they were happy holding my crocheted neuron. I was chatting with their mothers, with their families about what's the retina, how do we build the retina using stem cells, and I felt that this way was really helpful in simplifying a complex concept, science concept, in an easy, accessible way, easy to understand, especially for kids, and enjoyable at the same time. So they are enjoying holding these models, and they also chatting with me in a really nice language that they can understand. I also started to do some Photoshop illustration using my crocheted models, just to make the knowledge accessible for everyone. So anyone that follows me on social media, I usually post links to these illustrations, how the stem cells divide, how the retinal stem cell give all these kind of retinal cells, and how the retinal layers looks like, and different type of degenerative eye disease, and how and what the cell that is lost in every single type of this disease in a single illustration that can be also downloaded from anywhere, like from Etsy, from Redbubble, and people can also download it. So I started not only to illustrate, educate people around in science community or in public places, but also sharing my love to science to others who wanna purchase, for example, for themselves or for their nerdy, geeky friends, for example, or they wanna buy some brains, neurons, and even for kids, making some gliders in a adorable, funny way that kids can like it, and at the same time, in those posts, I also write some scientific background about these cells, so people can buy and can learn at the same time what are these cells and what they are used for. So I was really thrilled and grateful for all the feedback that whenever I post any illustrations, any crocheted work, I usually get a lot and tons of these positive, supporting comments over social media. and even in real life actually, and even people like tagging me, posting my stuff and tagging me once again and thanking me on sharing my passion to science and educating them at the same time. And even from those who attended all like the meta-neuron and all my workshop that I do, usually they really support me and they encourage me to do more workshop actually because they are really useful and informative at the same time. And even I feel like really happy when they go home, continue working with the pattern, whatever they do, and then they tag me once later on social media saying, hey, we finished this project. It's for a friend, it's for a psychiatric friend, it's for a clinician friend, or whatever. And this really like motivate me more and let me continue my creativity. I see stuff under a microscope. I feel creative and I do the art. So I like people really to feel my passion and to share me the same thing. And that was the beginning. So Neuron was the beginning for me to do real science crochet art. And I want to also to thank SciComm Toronto and Ontario Brain Institute and for Etsy Market and Maker Festival Market for allowing me to instruct these workshops. And at the end, I want to also thank everyone, the Outside Salon and the Field Institute for having me today. And also I want to thank my husband, my kids for being patient, following me during my PhD journey and my science communication, sci-art journey. And you don't know, every night I go to bed shredded into pieces, but their love and support are really the thing that glue me again, all my pieces every morning to do my research and my creativity and inspire others as well and motivate others to do the same thing. So thank you, and that's it.
We have plenty of time. We have a discussion. So all the speakers, please come over and. So we only have 3 microscope. So we'll do a little bit of dancing around with the microphones. And for those people in the audience, please do speak up. And I will try to repeat the questions so that people at home can actually hear. We have something like 15 people who are following right now. So yeah, it's kind of nice. Yep.
Hi, I've got a question for Matteo. I was fascinated with your talk. And I'm wondering if you consider what you're doing in science fiction. I know that might sound a bit of a strange question because there's a lot of generic expectations that there's going to be rockets and, I don't know, space operas or, there's actually many, many different branches of science fiction and it changes a lot over the history. It's 200 years of history. But even, in fact, when you look at what people say about trying to define science fiction, they there's no real consensus, the scholars. And so I always fall back when I look at, and I realize that lack of consensus, there's science and there's fiction. And they somehow come together. I don't know, so my question is kind of double-barreled. Do you have any identification with science fiction? And or do you recognize that could be called science fiction? I love the question because
Can you repeat that? Well, I can repeat it myself a lot, in a very summarized way. So, what is the relationship between your work and science fiction, and do you consider yourself as?
Good question, and I often think about it as well because it's definitely it is fiction. It's about science. It just doesn't fit the traditional, what became the traditional idea of science fiction. Future setting, the technology. But it's funny actually. I never know where to find my books. Sometimes they are in the comic section, sometimes they are in the science section. So I think people are confused about the definition. But I think in a way it's. I mean, I personally like this. Like, I think it's really the power of comics. They're very difficult to define. They don't really, especially the comic science, they don't really belong in any categories. And I think this can actually be helpful when we are trying to do science communication, because people don't constantly love all kinds of science communication, but I feel like it's often directed to very specific audiences. The same way for science fiction, like there are specific science fiction readers. And I would really like to break out of these boundaries, and like I would love to think people just pick up my books because they're comics. They never even thought about reading a book about science. They don't really care about science fiction. They just it's much more approachable work because they carry the same decades of other readers. So yeah, I would really like to redefine science fiction or science and fiction in different ways. That answer the question, but yeah, cool.
Sì, I wanted to ask a question to Alfonso. And he knows, but no one else knows. I'm an engineer, so I'm quite out of everything in this place. But I love this presentation because it stimulated my an idea in my. Like, as engineers and architects, we always have to make use of creativity. We are somehow artists, because now we have computers that does the real job of engineers, and we are the artists that use the computer in order to get all of what you see around in your everyday life. You analyzed patients, and you came at the end to see creativity, and you came back somehow to understand that some of the reason of this creativity were actually linked to the patient's attitude, behavior, character, and somehow were conditioned by their neurological situation. So now I'm asking you this thing, and it connects very much in what you say also, there is not much money for this research. Do you think there is a possibility or an advantage to induce creativity, maybe through those neurological processes that actually motivate a person through what you mentioned clearly is, I wouldn't say ambition, even you say better the desire to be noticed and to be acclaimed by the public. So if we can induce this back, then we can have more creativity into everyone, particularly into those jobs that really require it, and you can find money for that. Because we could be interested.
Thank you, Giuseppe. It's a challenging question, particularly coming from an engineer. And actually, it's probably the reason why you're asking the question, because this eternal the stereotype is that engineer, especially when you compare to architect, has no creativity. So a couple of things. First of all, creativity is part of us and makes us live. I mean, natural selection clearly tells us that with no creativity we will not be here. Probably, it's a possible way to go around problems. That's what makes us so smart sometimes, problem solving and these other things. So in a way we need creativity. The question is, can we treat creativity? Can we induce creativity? I happen to follow a few patients with writer's blocks, for instance. So writer's blocks is, for instance, the best example of how you can see different problems, because a writer is a good artist. He has the skills, he has the quality to do something good, but sometimes the missing part is that drive that starts a process. And it might be a bit too much to say you can give medication to these people, because I don't like this way of using medication as sort of a, for every problem there is a solution that is a tablet or a pill or a tablet. But in theory, medications can be used in this particular context. And this is, I guess, part of the reason some of the artists are actually self-medicating themselves sometimes with drugs. But that's another topic. As for your more practical question, which I fully agree, that is whether creativity can be taught, for instance. Yes and no. I think there is more that can be done, but if you're in marketing, for instance, you know that there is a lot of this kind of thing, for instance, neuromarketing or neuroeconomics, or in a way also teaches how to explore your own creativity, but it's very individual in the end, so it's very hard, I guess.
I just have two questions. One, if you could explain better what punding is. I'm curious of whether you consider it a mythology or if it's more of a kind of a name you give to a certain kind of compulsive behavior. And then I have a question for Shelley. I like very much what you had to say around how visual narratives allow the connection between explanation and exploration. Sometimes that distance that we put between a disease and an illness, right? The disease being the scientific definition of whatever's going on with you, and the illness your subjective experience. And I'm wondering as to just how much narrative and visual narrative bridges that, or can give back also to, if you want, the science of illness versus the science of disease.
Thank you. If I understand your question, it was about how narrative can bridge sort of science and the kind of humane sides of medicine.
Some visual narratives go beyond just being sort of illustrative, so being the scientific communication of stuff, and add something that something can actually speak back to science, I think, on some level, can it? With that exploration aspect, right?
Yes, I like that idea of speaking back to science. When you embody a concept in an image, in some ways it has to be more concrete. There's no hand waving in an illustration. And it embodies that concept. And I think that images can work with textual ideas in different ways. So they can simply amplify them. They can be completely congruent with the text. But I think where comics about illness become really interesting is when the visuals and the text are not doing exactly the same thing. I mean, that's when comics become really interesting, is when there's this creative interplay between seeing one thing and the text saying another, and then your mind has to make that connection. It becomes more active and engaged. And I think one of the values of narrative, whether it's visual or otherwise, is it kind of treads a human path through sort of epidemiological data, gives it a kind of focus, individual focus. So I think both those things are necessary in healthcare, and I think narratives are one way to make sure that aspect is there.
Yeah, punding. So what is punding? First of all, I didn't invent the term. As I said, this was used in the 70s, and it comes from Swedish. It means put something in your head and you cannot escape from it. So it's when you lose control over your own habits, basically. So you're doing something, you're used to do something, and you cannot keep doing that anymore. But your question is a good one, because it's very difficult to say when something is normal or not. I mean, you can speak with many psychiatrists, and nobody will probably agree on what normal, what is normal, what is not. I also need to make clear that it's not a compulsion, because technically to have a compulsion, you probably heard about OCD, obsessive compulsive disorder. In order to have a compulsion, you need to have an obsession. So actually OCD is categorized in the anxiety disorders. So you need to have a fear of dirty, for instance, and you wash your hand in a compulsive way. But going back to what is normal and what is not, for instance, in the movie, in the Kubrick's movie, we know that there is no normal for many reasons, but that is the moment in the movie when everybody realizes that Jack Nicholson is actually crazy, right? Because it looked like he was doing something normal, like typing every day, and then he was typing over and over again the same thing. A while back, I did an experiment that I published. I went to one of the patients' association meeting. It was like more or less a meeting like the same audience in terms of numbers that you see here today. And I gave to everyone a questionnaire asking whether they had, most of the people in the audience were Parkinson's patients, and asked whether they had an OB or not, or any type. So the questionnaire had 2 pages, and they were only asked to fill in the first page. And then I gave a lecture on what panding is. Actually, it can be very disrupting in families because people don't participate in the family life anymore. They spend all the day and night in the garden, for instance, or cooking or cleaning. And they say, no, that's normal to me. I always did this. But the difference is that you cannot stop doing that anymore. So when I gave the lecture about panding, then I asked the same people, okay, now turn your page and please ask again the same question. And I was impressed by a woman that actually this blue color recurs, because this woman in the first page said, yeah, my hobby is painting. I like painting a lot. Second page is, I actually paint everything of the color blue. Everything at my place is blue. It's actually like and you can clearly tell that another missing part here is awareness. People don't really realize when they're having the problem. Actually, it's the family that is bringing up. Now, is this something you need to treat all the time? No, not necessarily. Sometimes, people find a way. Actually, I have many wives that are happy that the husband is doing something else. But in some cases, it becomes too much. But the issue of panding here is brought to your attention just because I think it's a very interesting phenomenon that we haven't explored yet. It tells us a little bit more about when we get stuck in doing something, checking your emails all over and again, for instance, right? So we all are used to repetition of certain behaviors. Sometimes we lose control over them. Yeah, that's all.
Okay, so we have Igor first here, and then second.
I'm just listening to the first 2 presentations, and I have experience with social work, and I kept thinking. Matteo talked about emotional attachment to the comics, and then Shelley talked about, just how this makes it easier. And I wonder if there is experience that speaks to using this or understanding the neuroscience behind it in speaking to topics that have a lot of stigma or a lot of trauma involved in it, such that we don't want to underestimate the issue, but we just want to be able to talk to people so they understand and look at it from a different angle.
Who's going first?
I mean, I don't know anything specific about vision analysis. Maybe you know more about graphic medicine, it's more your field, but yeah, as I said, I've been reading a lot about studies on narrative in general, so text narratives. And yeah, that's really one of the main proposals for narratives in science or medicine, is that there are ways to address this complex subject, which we may have all sorts of cultural, psychological barriers, but when we are reading a narrative, there's this theory called transportation theory, for which if you are reading a good story and you actually identify with the character, then you momentarily, you are less attached to your own beliefs. You kind of experience the story through the character's eye, and so maybe you may also be more open to ideas, ethical, political topics which you wouldn't necessarily consider if they are presented in an expository way. So I think that's a very interesting potential for narrative. I don't know if what you were asking, but yeah, I think in medicine there's definitely support for that.
Yes. So when you say stigma, are you thinking mental illness, that kind of stigma?
My work right now is in the HIV sector, so sexual health, HIV itself, and yes, definitely mental health links in substance use even.
Yes, I think comics are a really valuable way of talking about stigmatized subjects, because that was the easy part of the sentence to get out. Well, I'm thinking in 2 directions that seem sort of almost contrary. There's an element of making visible. I mean, literally making something visible that is often hidden or might be kind of like obfuscated by really technical language, or so that making visible. But on the other hand, there's an element of making it making it a bit lighter. So there are elements of humor, in fact.
Sorry, I didn't.
Well, that's what question period is about. When you said stigma or difficult topics, actually the first thing that came to mind is this amazing sort of comic multimedia project called Priya's Shakti, which is specifically it's to raise awareness about and combat gender-based violence, and it is distributed in comic form, I think in villages in India where, and the character is this young Indian woman who has been raped by villagers, and she is visited by the goddess Priya, and gets this superpower, and her superpower is sort of the power of persuasion in a way, and education. And so I think comics are a way of also harnessing people's willingness to engage with those kind of stories, to tap onto that, to get people to engage with stories they might not want to deal with in other ways. I don't know if that answers your question. Thanks.
Just a chat. I don't know. I didn't see it, sorry.
Was she first?
Yeah, I think she was. Let me.
Okay. Michelle first and then. Sorry. I was looking in the back and I didn't look in the front. So.
Hey, first.
Because I know Michelle, she gets upset.
Presentation of Dr. Fasano, and so this discussion flowed, and thank you for talking about the darkness, because I don't see it having Parkinson's and start. But I have a question for Matteo and also yeah, and it's about narrative, because I'm writing a memoir about going through the experience of having Parkinson's, and I find that a lot of the writing doesn't necessarily focus on what I deal with on a daily basis per se, but just thoughts that I have and things that I go through that kind of venture outside of the disease, because when you have a disease, what is the disease and what is you, that separation becomes kind of liquid. So my question about narrative in science is one where I'm curious about when you were presenting the work examples in your work, how focused is it on the topic at hand, and how much kind of other stuff that makes, the character whole.
I mean, I don't know if I have enough to say about it, because the science I'm trying to present is very basic science. That's why I didn't really focus on human centered narrative. Because I didn't mention it because I assume you were going to talk about it. There is this related but separate field called graphic medicine, and this even broader field, the narrative medicine, which focuses much more on that, on the patient experience. Not only the patient experience, but the patient and doctor relationships, and trying to communicate the experience as a whole. So not just as you are saying, disease is not just a disease, it's also a person, and that's what often missing in patient-doctor communication. We also focus on symptoms. I think narrative medicine and graphic medicine are trying to bring with that. So definitely there's more in that field. In my case, I'm not really trying to tell anyone's story. I'm trying to really make more accessible this more basic concepts.
But if we bring it more towards the graphic novel category, and we use a narrative like Chris Ware, for example, who's dealing with the sexes and relationships and breaking the flow of A to B kind of traditional linear narrative, and thoughts and different things come into his graphic novels.
Yeah, no, I think that Chris Ware is an excellent example, and I think in general, like in graphic medicine, is in a way like he's already doing all the things I've been talking about and more. I think he's much more ahead as a field for two reasons. Partly because graphic novels, as a genre, they're much more associated with the graphic memoir. So I think that comics are very good to visualize and tell these very personal, intimate stories. I don't know for what reason exactly, but yeah, so graphic medicine really started from that. And partly because, as I was saying, I think we are very self-absorbed animals, and so stories about humans and medical histories are much more relatable. But yeah, you're really the expert of graphic medicine.
No,
She organized a
That's why I didn't go there.
Not even why you didn't go there.
I mean, like answering the question.
Yes.
So you are yes.
Yes, I mean, it is the story. I mean, Parkinson's is one aspect of life, but it's not. Yes, the disease doesn't define the person, obviously, and I think in a way that's where those kind of narratives are really valuable, like the narratives that you're writing. It's not this is the patient with Parkinson's disease, that is her identity. It's no, there's a whole other person there who's not necessarily. I mean, obviously you have a relationship, but I think the patient is not necessarily seen in that way. You know, they're seen as a symptom, and I think I've heard patients refer to themselves as say, "I'm a kidney transplant." You know, well, no, that's one thing that happened to you, but I think that's where narrative is helpful, is in pushing against that tendency to identify a person as, oh, that's the person with CP, or, you know, oh, that's this person who has this disorder, and therefore that defines them. Another thing I'd like to say about what I was talking about, one of the reasons I wanted to show Peter Dunlap Scholl's work is that he is writing from the patient's perspective. His goal is partly to explain what it's like for him, but also he wants to educate people, because as I'm sure you know, Parkinson's isn't understood by a lot of people. People misinterpret. It must probably misinterpret you sometimes, or don't understand something. You know, there are things that people don't understand about, you know, what someone with Parkinson's needs, or. But that's not my story. My story can only be the story of someone outside trying to understand. So I want to be very clear that I don't feel like I can tell someone else's story. All I can reflect on is, an interpersonal relationship in the context of that illness.
Well, that's a good point. I also want to add, I'm not trying to write anyone's story.
That I don't have any experience. I think we that has to come from the patient or
collaboration between doctor and patient.
Super question, Alfonso. You mentioned that creativity obviously is not an area that gets a lot of funding. And I was wondering what you felt would be the area of research that would be most likely to make developments in that area. Is it Parkinson's? Is it drugs and behavior? But where do you see movement going or coming from in that area?
Last part, where do you see?
Where do you see any development or movement in the area of creativity research coming from?
I said this is my own hobby. Maybe I'm losing control over my own hobby now. So I'm probably not the right person to ask this question, but I realize that I'm the one that brought this up, so I need to find an answer now. So I think certainly it's not the Parkinson's field. It's probably not even neurology. It's probably more cognitive science. not even psychiatry, I think, because psychiatry, they always look, the pathological aspects. We are talking about a very important human function, which is very, very much needed, and we have it. And there are a few things that make us humans. One of them is creativity. The other ones will be religion. Maybe the other one will be walking on two limbs. That's why another field of interest of mine is gait. But as you said, I come from a movement, knowledge, being a Parkinson's disease specialist. I happen to see this phenomenon, and that's why I got interested. But most of what is done in creativity actually comes from, as I said, cognitive science, and particularly comes from the literature looking at teenagers and learning, evolution of the individual, and also maybe connecting this to what Giuseppe was asking before. Maybe our way of teaching what we learn at school is completely wrong. We need to explain and teach creativity, or helping people to find their own creativity, because creativity is embedded in anyone. So this is where I see the field going. But for sure there is not enough funding. For sure there's need to understand more, and probably there's a practical reason to understand creativity, because it can help us more. Maybe we won't have Trump as a president in the U.S. if there was more creativity. Who knows? Although I should say that even there's a lot of creativity. So, yeah.
We're going to take the last two questions because it's time to go and we have to let those people go to the past. So one and two.
I want to ask a question about stigma, a different aspect of that question. About 25 years ago, I did research in the relation between science and humanities. Specifically, I looked at for maybe a year and a half about how mathematicians try and speak in layperson's terms about their inventions and their discoveries, whatever they are. Mistakes, yes? Mathematical stuff. And at that time, there wasn't this science com. It didn't exist, I think. And what did exist, and this is one of my questions leading, was there was a great deal of stigma to those, either mathematicians or sort of science journalists, if you can call them that, who tried to talk in these terms to laypersons about mathematical discoveries and inventions. There was a great deal of stigma. And a lot of those people talked about feeling coward by going out in public and talking in those terms on their colleagues, the hard and sort of disciplinarian types in their field. I'm wondering if you have any of you experienced anything like that.
I'm a physics professor. I've done outreach. We call it outreach in order to disguise the fact that we actually enjoy talking to the public. We pretend that it's some kind of duty that we have to perform done outreach for decades. And yeah, that's a huge effect. Huge effect. People usually say, "Oh, Steve, I'm glad you're doing this for us." Like patting me on the head and saying, "It's good that you're sacrificing your career so that I don't have to do this." Or, "Oh, you're helping the public understand physics so that they'll fund me more." That's a very common attitude. And thank God I don't have to do it because you're doing it. You're going out there and prostituting yourself, or sacrificing your time, your valuable time, and all this stuff. And the idea that you might actually feel this is fun, that's not. And so you're not supposed to be having fun. You're supposed to be doing serious. Yeah, it's a huge effect. It's probably biggest in mathematicians and people who have the toughest jobs for speaking to the public. There's an old joke that says, the biologist can talk to chemists, chemists can talk to physicists, physicists can talk to mathematicians, but mathematicians can only talk to God.
What about you? Because this was also one of my questions. Like sometimes when you're doing craft or when you're doing other, like you're doing comics, this might be perceived as more trivialized. Or when you're like putting art in your profession, like you say that this is only your master. And so I'm wondering why. So like I think this ties into this question.
For my, yeah, because for myself. Well, I told him about my passion and about my retinal crochet stuff, but he never responded to me at all. The only thing that he said, "Hey Tahani, do you have time to do this?" And I say, with myself, I say yes, I like it, so I have time to it. And even my friends, there is some supportive friends, and there is others who discourage me a lot. What are you doing do you have time with kids and with your PhD to do crochet? So it was really, I do have time because I love it. So once they go to sleep and I start thinking about science, I start to do stitches instead of reading papers sometimes. So, if you have the passion, you're going to find the time. And because I'm sharing the science through these models, so nowadays it's more like science communication for me. I explain my science, I explain my research through these posts. So I'm not wasting time actually. I'm teaching myself and I'm teaching others as well. So this is like 2 in 1, and I'm learning a lot from this. Because I am now crocheting things that out of my field now sometimes. And in order to put a post on Instagram or on Twitter explaining these things that is not in my field, but I've crocheted for it, it let me read a lot about this and educate myself in other fields. And this is really educational for me. It's not just a waste of time, right? And even it teach me how to simplify concepts in a really easy way. Especially when I take my things to elementary school or kindergarten sometimes, I try to simplify my words so that kindergarten students can learn and can understand what I say, right? So it's not a waste of time. It's a fun, enjoyable way to share my science and to learn more. Right?
I'm wondering if that's maybe easier to
Well, sometimes I like to crochet more than any other things, actually. And I like to repeat stitches over stitches over stitches.
Then you've got a lot of wonders here.
I consider it like escape from the stress of my research and from my graduate studies as well.
Yeah, you're not supposed to have that. We both have another question. Sorry, Steven, you have to be on the line. Sorry.
Just a quick question. So all of the talks are really wonderful, but I was thinking about Tahani's talk and Matteo's talk. You traced out this beautiful line of starting as scientists and sort of finding yourself as artists, and then also returning to the science occasionally. So I was wondering if that journey of finding yourself as artists reshifted your thinking of how you thought about the science. So if you had any kinds of new insights that came from your artistic practice. So Tahani, you talked about patterns and stitches. Do those let you into the scientific work in a new way? Matteo, you talked about narrative, you talked about reading about narrative, but did your own narrative constructions let you see something new that you hadn't seen before?
With the end of the microscope, I started to do for my
So, can't hear you.
Whatever type of cell under the microscope, the first thing I started to think about is how to protect this. How to make what
they have here in the back.
Okay. So and I forgot that I have this thing. Anyway. So the first thing that I feel like creative and how I'm gonna crochet this cell, and I start to think about my next Instagram post, what I'm gonna tell my followers and my science creative fellows about this cell. So it really inspires me, like science inspires me to do art actually nowadays.
Yeah, it's interesting. This is a question I get a lot, actually.
Of course.
No, I was noticing the similarity in our paths as well. And Yeah, I think definitely for me it was very eye-opening to think about narrative and metaphors, which
Shelley mentioned as well, which
being a scientist, we already use all the time. So when we write our article, like the classic structure, introduction, method, results, conclusion, is a narrative structure. And like we use metaphors, like we really couldn't even work without metaphors, definitely in neuroscience, which is about dendritic branches and our
organization. So those are
metaphors from the surface. It's just like we are not really trained to think
about these things. So we just do it.
Without really knowing what we're doing. And I think there is definitely a value in I like overthinking. I feel like I would like to see scientists trained in the thing, like understand why we use metaphors and how we tell stories and what are the effects of the metaphors and the stories. And also, I just wanted to briefly answer the question about stigma, because
I feel like
in our case,
it might take a positive note maybe. In my case, it really worked out. Like I was very worried at the beginning, as I mentioned. But now, I guess it helps definitely to have the support of important institutions like the Weapon Trust. So we should really acknowledge them and hope that they continue. But the proof that I went back to research, I never thought I could find a way back to academia. After drawing comics for 4 years, I reflected. So many things are changed. But I think also, does anyone else have to say about this? I want to add another thing about stigma as well, because I think it goes both ways. In the end, stigma is like people don't understand it. So there's definitely the stigma of the scientists against educators, but I always felt somewhat also the
artist and
the life of the
lab. I feel like there was a
stigma of the outside world against scientists. Like you're doing something very complex and impossible to understand. And I think what we are doing, I hope kind of breaks down the stigma as well. So I'm not even trying to teach people science. I really want to change the perception of science. Yeah,
it's not something
completely out there you could never understand. You can crochet, you can make a comic about it. There's nothing to be scared of. And that's, I think, is that's for me the important part.
Okay, I think we can conclude here. Also because it's already 10 past 8. It's late, sorry. Sorry, Nina. We could stay